Have you ever looked up at a plane soaring through the sky and wondered how it moves so gracefully in 3 dimensions? The answer lies in ingenious devices called control surfaces. These are small, movable sections on the wings and tail that might seem insignificant, but they hold the key to controlled flight. Without them, planes would be like rudderless boats, tossed around by the whims of the wind. Control surfaces are like the steering wheel and pedals of the sky. They give pilots the power to maneuver the aircraft, allowing them to climb, descend, turn, and even perform daring aerial maneuvers. Imagine trying to drive a car without a steering wheel or brakes. That's what flying would be like without these vital components. But how do these seemingly simple surfaces exert such precise control over a massive metal bird weighing tons? Let's delve into the fascinating world of ailerons, elevators, and rudders to understand their individual roles in making flight possible. Fasten your seatbelts. It's going to be an exciting ride. Ailerons are like the magic wands that make airplanes turn left or right. These hinged surfaces are located on the trailing edge of each wing towards the wingtips. When a pilot wants to turn, they move the control stick left or right, which activates the ailerons. To initiate a left turn, the left aileron goes up and the right aileron goes down. The raised aileron disrupts the airflow, creating less lift. The lowered aileron on the opposite wing increases lift. This difference in lift causes the plane to bank towards the side with the lowered aileron. The ailerons create a seesaw effect, allowing the plane to smoothly bank into a turn. Elevators, as their name suggests, are all about controlling the pitch of the aircraft, whether it's climbing to cruising altitude or making a smooth descent for landing. These control surfaces are typically located on the horizontal stabilizer, which is the smaller wing-like structure at the tail of the plane. When a pilot pulls back on the control stick, the elevators move upwards. This upward movement disrupts the airflow over the tail, creating a downward force. This downward force pitches the nose of the plane upwards, causing it to climb. Conversely, pushing the control stick forward lowers the elevators, reducing the downward force on the tail and allowing the nose to drop, initiating a descent. The elevators are essentially the plane's up and down controls, allowing pilots to precisely adjust the aircraft's altitude. Imagine trying to climb a mountain road in a car without an accelerator or brake pedal. It would be a jerky and uncontrollable ride. Elevators provide that crucial control over the plane's vertical movement, making for a smooth and comfortable flight. Section 4. Rudders, steering through the skies. Now, imagine you're driving a car and you want to stay perfectly within your lane. You use the steering wheel to make small adjustments, right? In an aircraft, the rudder acts like that steering wheel, controlling the left or right movement of the nose. The rudder is a large, movable surface located on the vertical stabilizer, which is the tall, fin-like structure at the back of the plane. When a pilot pushes the left rudder pedal, the rudder deflects to the left. This deflection disrupts the airflow, creating a sideways force that pushes the tail to the right, causing the nose to swing left. While the rudder is primarily used for keeping the plane flying straight, it also plays a crucial role in coordinated turns. Remember those ailerons we talked about? They bank the plane, but to prevent an uncoordinated skidding turn, the rudder is used in conjunction with the ailerons. This coordinated use of both control surfaces allows the plane to turn smoothly and efficiently. Section 5. Engineering marvels. Precision in every design. Behind the seeming simplicity of these control surfaces lies a world of complex engineering. Every curve, every angle, every material choice is a result of careful calculation and testing. Engineers use sophisticated computer simulations and wind tunnel testing to refine the design. These engineers ensure that aircraft can soar through the skies with precision and grace. Remember the crucial role played by those small but mighty control surfaces.